welcome back to Alia Pooch. Today I am here with a new topic, linear magnification. So, what is magnification? Magnification is the ratio of height of image to the height of object. M is equal to height of image to the height of object. Magnification is also the ratio of image distance to the object distance. Now, when I say image distance, what I mean is the distance between the image from the pole of the mirror. And similarly, when I say object distance, I mean the distance of the object from the pole of the mirror. Now, we'll be discussing about magnification in both the cases. The case of concave and convex. Concave and convex. Now, the first thing is the height of object. Height of object in both the cases is taken positive because object is always placed erect and the object is always upward and perpendicular to the principal axis. And as per sign convention, the distances measured upward and perpendicular to the principal axis are always taken positive. Similarly, in case of convex mirror, height of object is taken positive. Now, case of height of image. Height of image in case of concave mirror can be positive or negative. Now, height of image can be positive when the image formed is upward and perpendicular to the principal axis. Like for example, when object is placed between P and F, then a virtual and direct image is formed. Erect images are perpendicular and upward to the principal axis. So height of image is positive. Now height of image can be negative. Like for example, if I place the object beyond C, then the image formed would be real and inverted. Now inverted images are downward and perpendicular to the principal axis. And as per sign convention, the distances measured downward and perpendicular to the principal axis are always taken negative. And in case of convex mirror, height of image is always taken positive. Because in case of convex mirror, the image formed is virtual and direct in all the cases. And erect images are upward and perpendicular to the principal axis, and as per sign convention, the distances measured upward and perpendicular to the principal axis are always taken positive. Example is all cases. In all cases, the image formed is virtual and direct. Now, our next thing is object distance U. U for both the cases is negative because as per sign convention, the object is always placed on the left hand side, and as per sign convention, the distances measured against the direction of incident ray are taken negative. Object distance in both the cases is taken negative. Now, our image distance V. In case of concave mirror, it is taken positive or negative. It is taken positive when the image formed is virtual and direct. Because the virtual images are always formed on the right hand side. So the distances measured in the same direction of the incident ray are taken positive as per sign conventions. Like for example, if I am placing an object between P and F, so the height of image would be taken positive. Now the image distance is taken negative when the image formed is real and inverted. Because as per sign convention, because the real images are formed on the left side, and as per sign convention, the distances measured against the direction of incident ray are always taken negative. Like for example, if I am placing an object beyond C, then the image formed is real. That is formed on the left hand side between C and F. So the distance is measured. So as per sign convention, the distance is measured against the direction of incident ray are taken negative. Now in case of convex mirror, V is taken positive. Because in case of convex mirror, the image formed is always virtual and the image formed is on right hand side, and so the distances measured in the same direction of incident ray are taken positive. So V for all the cases of a convex mirror is taken positive. Now M can be more than 1, less than 1 or equal to 1. In case of concave mirror, M can be more than 1 or M can be less than 1. M can be more than 1 when the image formed is enlarged. Like for example, if I am placing an object between C and F, or I am placing it at F or between P and F, the image formed is enlarged in these cases. So M is greater than 1 in these cases. M is less than 1 when image formed is diminished. Like I am placing object at infinity, then the image is highly diminished and point sized. Or I am placing the object beyond C, then the image formed is diminished. So in these cases, M is less than 1. In case of convex mirror, M is always less than 1. Because in all the cases of convex mirror, the image formed is diminished. So M is less than 1. In this case, now in case of plane mirror, M is equal to 1. Like if height of, for example, height of image I am taking in case of plane mirror, 5 centimeters suppose. Height of object is also 5 centimeter. Because in a plane mirror, height of image is equal to height of object. So then magnification is equal to 5 upon 5, that is 1. So image formed has magnification 1 only. In case of convex mirror, the image formed is diminished. Like if height of object I am taking 5 centimeters suppose, then the image formed is suppose 2 centimeters. Because image formed is diminished, so 2 upon 5 is magnification. Now because image is diminished, then the magnification is less than 1, but magnification is positive. Because in all the cases of convex mirror, the image formed is virtual. Like here if I say, then the image formed would be 0.4. So because the image is erect in all the cases of a convex mirror, the height of image, the magnification would be positive but less than 1. Like point something. Like in this case it is 0.4. Now let's talk about the case where M is equal to -1. Now think, how is it possible? It is possible in case of concave mirror, when object is placed at the center of curvature. When object is placed at the center of curvature, then the image formed is of same size. Now because the image is erect in all the cases of a concave mirror, the magnification would be positive but magnification is less than 1. Like point something. Like in this case it is 0.4. Now let's talk about the case where M is equal to -1. Now think, how is it possible? It is possible in case of concave mirror, when object is placed at the center of curvature. When object is placed at the center of curvature, then the image formed is of same size. the image formed is same size and it is formed just below. It is also formed at C. And the image is inverted. Now because the image is of same size, then m equal to 1. But because the image is inverted, then m is equal to minus 1. So when object is placed at C, then magnification is equal to minus 1. So that was all for today's tutorial. Keep liking, keep subscribing and keep suggesting how can I make the video better. Also press the bell icon below to get the notifications for the latest videos I am uploading. Thanks for watching. Bye bye.